Okay, so these three problems that come one right after the other are all binomial distribution problems. So let's look at one of them, and it's probably going to answer your questions for pretty much all of them. So a company prices its tornado insurance using the following assumptions. In any calendar year, there can be at most one tornado. In any calendar year, the probability of a tornado is 0.13. The number of tornadoes in any calendar year is independent of the number of tornadoes in any other calendar year. So those are all of our essential components to tell us it's a binomial distribution. So using the company's assumptions, calculate the probability that there are fewer than four tornadoes in a 14-year period. All right, so this is our probability of having a tornado, 0.13. We're going to have 14 years, so that's the number of trials, and fewer than 4. So we want to find the probability of less than 4. All right, so let me go to Excel, and we're finding the probability that X is less than 4. We had 14 trials, and our probability is 0.13. Now, what's very important in here when we use the binomial distribution in Excel, the binomial distribution is a discrete probability distribution. So if we're looking at values that are X that are less than 4, that's 0, 1, 2, and 3. We can't put a 4 in here for our X value because that would also include 4. So what we need to do is put in 3 instead of 4 because the next discrete value less than 4 is 3. So that's going to give us X's 0, 1, 2, and 3, which is what we're really looking for. All right, and our trials are 14. Our probability is 0.13, and then we put the word true for cumulative. And then that gives us our answer of 0.9021. And of course, over here in your homework, if we, I don't know if you can show the answer. I don't think you can, but of course that's exactly what we're looking at right there. Now, the second problem here is exactly the same kind of problem, but we have to pay attention to the wording on each one of these. So find the probability that there are fewer than 2 is exactly like the problem we just did. All right, where X is 2, and it looks like 15 is our N, and our probability of unemployment is 0.079 as a decimal. On the other hand, C, find the probability that there are more than 2 would be things like 3, 4, 5, 6, all the way up to 15. So more than 2, what you need to do is do the probability putting a 2 in for X. Get that answer. That gives you the probability that X is less than or equal to 2. And then you'll subtract from 1 to get more than 2. And then D, find the probability that there are at most 2. Well, you will have actually already have done part of that, or really the answer to that question in C. You just did more than that in C. At most 2 means we could have 0, 1, or 2. So again, you'll put 2 in for X in your binomial distribution. And then whatever you get ends up being the answer that goes here. And hopefully that takes care of the next one along the way as well. Okay, so yeah, so you just need to pay attention to the wording. Now let's see, the only one I see that's slightly different will be if you were between 2 and 5. So you binomial distribution in Excel for 2 with X equals 2, and then you'll do it with X equals 5, and you'll subtract these two values. 2 prizes or fewer, you'll put in a value of 2. Probability that you win exactly 3, you're going to put in the probability of X equals 3, and then you're going to put in the probability that X equals 2 and subtract them. And I think that will take care of those. And let's see. Same sort of problem in your next one as well. All right, and then let's see, I think you had one other. Okay, so this was a z-score. So this means normally distributed, and of course we see the words normally distributed in the problem. Assume that z-scores are normally distributed with a mean of 0 and a standard deviation of 1. And we want to find the probability that z is between negative b and b, and the probability or the area under the curve between those two values is 0.984. Find B. Okay, so let's see. I'll do it in Excel. Let's see, what was that probability again? 0.984. Okay, so remember that our normal curve is a nice symmetric curve. In fact, I might even kind of have one drawn right here from having done the thing for you all's project. Okay, but we're looking for, and this is messy, just ignore all the numbers on here, but we're looking for a, whatever the value is for negative b right here, and I can't draw very well, and for positive b right here, and we want all this area that's in here to be equal to 0.984. But what we've got to think about is that if this is equal to 0.984, then what's left over on this side and this side have to add up along with 0.984 to 1. So let's first see what area is left over when we subtract 0.984 from 1. And that's going to be 0.016. All right, and then there are two places where we'll have 0.016. So if these two together, these two pieces of area have to equal 0.016. If we divide them by 0.016 by 2, that will tell us how much this area is over here, because these are symmetric. All right, so we divide that by 2, and that's 0.008. And since I know the area over to the left is 0.08, and by using in Excel my little equal norm.inv 0.008, and actually it's norm.s.inv 0.008, that gives me, well, let me do it again. I think I might have forgotten something. There it is. That gives me a z value of negative 2.409. Now, I wasn't sure decimals, but we're going to have two of them. All right. Now, it only wants you to do the positive ones, so we would report to it negative. We would report 2.409 as a positive number, and doesn't really tell you how many to round to. But looks like it took it all the way at 0.40892. But hopefully that will help you through these problems.